morning, students. We're going to give this another try. Loom, lovely program that it is, ate the video that I shot this morning when I had a couple people actually dialing in. So we're going to try and reshoot this one. We're going to be talking today and looking at some examples of resistance problems. We're going to be using this formula right here, which is called Ohm's law, named after the guy that we use his name as a unit of resistance, where resistance is equal to potential difference or voltage divided by current. Now we can get a couple interesting things out of this. First of all, we can make a magic triangle, putting V on top over I and R. We also want to keep in mind the goofy thing that I mentioned in yesterday's video. PVC is sick. This is a way for us to remember that in a parallel circuit, voltage is constant at all points through that circuit, and in a series circuit, current is constant at all points in that circuit. So if you haven't watched yesterday's video, you might want to pause this and go watch that one first, because it will help a lot of this to make a little more sense than what you're seeing right here. But we're going to take a look at a few practice problems. Going to jump in. Let's take a look at practice problem number 2. Okay, a toaster has a resistance of 20 ohms. Households have a voltage of 110 volts. So what current passes through a toaster? So we are looking for I. If we use our magic triangle to find I, we're going to be taking voltage divided by resistance. So let's come down here and look at number 2. So number 2, I equals V over R, which would mean our voltage here is 110 volts. Our resistance is 20 ohms. So it's just going to be 110 divided by 20. When I plug that into my glare calculator, I get an answer of 5.5. Since we're talking about current, it's going to be 5.5 amps. And they're just that simple. Let's hop down a little bit and take a look at some of these that aren't word problems. These might be a good place for you to actually start. And let's take a look here at, let's do number 6. Number 6, they want us to find the unknown quantity. They give us a current of 15 amps, voltage of 110 volts, and they want us to find resistance. So again, using our magic triangle, V over I and R, we're looking for R. We're going to do V divided by I, so voltage divided by current. So in this case, it's going to be 110 divided by 15. Calculator. Here we go. So that gives us a resistance of 7.33 ohms. So 7.33 omega. All right, so let's see. We've done one where we solved for current. We've done one where we solved for resistance. Let's do one where we solve for voltage. I guess we'll do number 4. So find the unknown quantity. If current is 10 amps, resistance is 1500 ohms. So to solve for voltage, we cover up the V, and we have I times R. So it's just going to be 10 times 1500. So that's going to give us 15,000 volts. Sounds like a lot. But the rest of those are fairly easy for you to piece together. Just use your magic triangle and solve for what you're missing. Now we've got a few more word problems down here at the bottom. I'm going to give you just a couple heads up on this. They do try and throw a few units at you, but it tries to be nice and fill you in on that. So if we've got a current of 25 milliamps and we need to change that into amps, you're going to divide by 1,000 because milli means 1,000. So when we divide this by 1,000, 25 milliamps is actually 0.025 amps. We move the decimal place 3 spots. Down here on number 12, they give us milliohms of resistance. They say that the human body only has 1 milliohm of resistance. So since milli still means 1/1000th, we're going to take 1 divided by 1,000, and it's going to be 0.001 ohm. Okay. It also gives you 1.21 gigavolts, but it goes ahead and it converts that for you into, good grief, a whole lot of volts. So that's page 1. Page 1 is relatively simple. I'm going to flip over and look at page 2 now. On page 2, we're going to be looking at some examples of both series and parallel circuits. And so, again, here are the little cheat sheet things. Remember, in a series circuit, current is constant, and to find resistance in a series circuit, you're going to add up all of the resistors to get a total equivalent resistance. In a parallel circuit, it's a little bit trickier. Voltage is constant at all points in the circuit, and to find resistance, you actually take the inverse. So 1 over your first resistance plus 1 over your second resistance and so on equals 1 over your total or equivalent resistance. And that'll come into play in the following problems. Let's take a look here. First of all, it wants us to do a series problem. It wants us to find equivalent resistance. So I'm going to look at B. Since these are series, in order to find series, you're just adding up your resistors. And so this is going to simply be 7,500 plus 1,500 plus 25. And I'm going to try and math that in my head. That would be 9,025. So I could do 9,025 ohms. And it's just that easy. Let's take a look at letter E down here. Now, because these are a parallel circuit, it's actually going to be 1 over each of these equals 1 over our total. So let me scoot this over and give myself a little more room to work. So it's actually going to be 1 over 2 plus 1 over 2 plus 1 over 5. 1/2 plus 1/2 plus 1/5 equals 1 over our total. Now be careful about this very last step. You might get into your calculator, and whether you decide to do this as decimals or whether you decide to do this as fractions, you might forget that that's going to give you the inverse of your answer. So what I'm going to do when I put this in my calculator, instead of putting these all in as fractions, I'm just going to go 1 divided by 2, 1 divided by 2, and 1 divided by 5 is going to give me my inverse answer. So I'm going to go 1 divided by 2 plus 1 divided by 2 plus 1 divided by 5. That gives me 1.2. Now be careful, that's not your answer. You need to go 1 divided by that. 1 divided by answer in order to find your actual answer. My actual answer is 0.833 repeating ohms. So I'm going to put that down. I'm just going to put down 0.83 ohms. That would be just fine. And yes, you could probably do the same thing. If you happen to know what these are as decimals, you could go 0.5 plus 0.5 plus 0.2. And then again, don't forget to take your reciprocal of your answer. Now we're going to come down to the final section here, where they actually show us some circuits and they want us to find the total resistance of the entire thing. Now G and H shouldn't present much of a problem to you because both G and H are parallel circuits. You can tell it's a parallel circuit because if you look, there's more than one pathway that the electricity can take to make a complete circuit. Same thing over here with H. There's actually 3 different pathways it can take. So you're going to follow the rules for parallel, which is 1 over each one equals 1 over your total. But when we get down to letter I and letter J, we've got some complex circuits going on. And let me show you what I mean. you can actually see parts of this that are series and parallel. So if you look here on letter I, this portion right here, these resistors are in series with each other. But then you can also argue that this entire thing up here is in series with both of them. However, this top part is wired in parallel. And in a similar fashion over here on J, these two are in parallel to one another, but they are all together in series with this 8 ohm resistor down here. So what we have to do is we have to kind of consider the entire circuit and sort of solve it from the inside out. So what I'm going to do first of all, since these are in series with this guy here, I'm going to find my equivalent resistance for just this portion. So that's 12 ohm and 5 ohm, so it's going to be 1/12 plus 1/5 equals 1 over the total. So I start off by doing 1 divided by 12 plus 1 divided by 5. And I'm going to do 1 divided by my answer to flip it back over. So that tells me that the total resistance for just this portion right here is 3.53 ohms. So I'm going to do 3.53 for this portion. And then since it is in series with this right here, I'm going to follow the rules for adding up series resistance, which just means I'm going to take 8 plus 3.53. So it's going to be, for J, 11.53 ohms. And you solve I in a similar fashion to that. You're going to find your parallel, and then you're going to put it in series with these other two resistors down here to find your total resistance. So I hope that has been of some help to you. If you have any questions, feel free to put it up in a comment on Google Classroom, or catch me during one of my help desk sessions. I'll be in today at both 3 o'clock and 6 o'clock, so come find me then. Good luck.